Welcome back to another round of Advent of Code. It's day 16 now. It's a bit late in the evening here and I don't feel like I'm quite firing on all cylinders, but we can only do our best. Let's have a look at the problem. What's the next disaster that's going to befall this holiday? We're catching another flight on a train. I like trains. Train ticket is in a funny language. Okay, we've got to read it. You can't read the words, but you can read the numbers. So we figured out what fields, what the values are. We got the rules for the ticket fields, the numbers on the ticket, and the numbers on other tickets for the same train service. Because we looked at the cameras, not sure how we did that. Okay, and we've got our input. The rules for the ticket fields specify a list of fields that exist somewhere on the ticket and the valid ranges of values for each field. So a rule that says class 1 to 3 or 5 to 7 means that one of the fields in each ticket is named class, and you've got to be in 1 to 3 or 5 to 7, but not 4. Each ticket is represented by a single line of comma-separated values. The values are the numbers on the ticket in the order they appear. Every ticket looks the same. So question marks means who knows. This ticket might be represented as RC. So this ticket, we can't read the words, but we can read the numbers. So we write it down as 101, 102, 103, 104, 301, 302, 334, which is the same order. In any case, you've extracted just the numbers in such a way that the order is the same. Yeah. Okay. Start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. So if we spot a number and it can't possibly match any of the rules, then we know that ticket is garbage. Ignore your own ticket. For example, suppose you have the following notes. We've got class, row, seat. So if you read a number like 99, you know it's buggered. Yeah, like 55. It doesn't match any of these rules. It doesn't matter which position corresponds to which field. You can identify invalid nearby tickets by considering... yeah. So you're a good, you're bad, because none of these can possibly be a 4. Yeah. This is not true of the other ones. Adding together all of the invalid values reduces your ticket scanning error rate. Okay, so we're not trying necessarily to identify which tickets are invalid, but which values are invalid. Yeah, adding together all of the invalid values produces your ticket scanning error rate. So yeah, it's that up, that, and that, and that. So just figure out which ones are invalid. Okay, very well. Let's have a look at our input. Oh, so we've got field, 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 field. Every single one of them is a pair of ranges. And we've got my ticket and we've got nearby tickets. So this looks like one. You could try to parse it, but it seems like actually a bit awkward to parse by hand. So maybe we'll just cheat. I don't mind a bit of cheating. So here we go. Here are our rules. And what we can do here is we can go do a bit of Emacs magic. There we go. And then we'll change all those ors into commas. All right. And then we'll do a bit more Emacs magic. I did that right. I think I did that right. If not, I'm going to get strange errors that don't make any sense. Bit more fiddling about. So now I've got every rule is just a pair of pairs, where each inner pair is a range. So my rules are, unfortunately I've lost the strings. That was probably a bit careless. We'll put them back. We'll put them back later if we need them. Surely we will need them in part 2. So now we have rules, and now we can just write, a function like valid for a given rule. So it takes a rule, which is a pair A, B, C, D, or a pair of pairs, and a value x, and we say this is valid if it's in. In's a keyword. Can't use in. I will just say within. You can say if x is within AB or x is within CD, where within, where a value y is within a range lower upper if L is less than equal to y and y is within u. So now I can ask, and now I can say, we call that valid 1, like valid for a single rule, and we can say valid for a set of rules, x is just if any of the rules match. So any rule is such that valid 1 are x in the rules. In fact, we'll just hard code our rules and just fix it to our rules. Any rules. And we can do a bit more magic. Make it even neater. There we go. Oops. Maybe I shouldn't be trying to do silly things. Let's put it back. There we go. What happened there? Why did that go wrong? Because it's... Yeah, we won't try to do silly things. So now we can ask, is 0 valid? No. Is 31 valid? Yes, because I can see it in that first set of rules. And we can just go something like filter valid 1 to 1,000 and see. Yeah, they look right. Like 974 is the last one, and I can see 974. Yeah. And now what I have to do, I have to take all the nearby tickets. In this example, the values on the first nearby ticket are value. Yeah. Consider the valid. Okay, so where are my nearby tickets? Nearby tickets. Goodness me, look at them all. All right, here we go. Nearby equals. Now we're going to have to do a bit of processing on these. So we'll turn each one into a list. Isn't this good fun, cheating instead of parsing? All right, there we go. Stick that on the end. Stick that there. Does it like that? No, it doesn't like that. We've got to move it across a bit. There we go. Okay. 241. Does that sound right? From 266. Yep, that's good. Okay, let's put things back the way they were. So now I've got all my nearby tickets. What if we go app filter valid on all of my nearby tickets? So what this should do, I might just do this like this. But it's actually invalid. It's more interesting, isn't it? Okay, so let's pick out for each of the nearby tickets, let's pick out the invalid numbers and print them out. So there you go. So for each of the nearby tickets, those are the ones that are invalid. And do we see 8 in here? Yeah, there it is, right at the end. Okay, so I think that's good. So I think all invalids are exactly what I just wrote. Let's grab that, but don't print them out. Just do that. There they are. Should be that. So far, so good. Now that you've identified which tickets contain, I haven't actually done that, but I sort of have. discard those tickets. So any tickets that have invalid values, throw them away. Done. So why don't we just, no, we'll read the problem first. Using the valid range for each field, determine what order the fields appear on the tickets. The order is consistent between all tickets. If seat is the third field, then it is the third field everywhere, including my ticket. For example, suppose you have these notes. Based on the nearby tickets, the first position must be row. So you can look at these. No, yeah, I think I can see where we're going here. Based on the nearby tickets, the first position must be row, the second position must be class, and the third position must be seat. And therefore that we can interpret our own ticket. Once you work out which field is which, look for the 6 fields on your ticket that start with the word departure and multiply them together. Okay. So we're interested in those first 6 rules. Those are the interesting ones. So I'm curious about this. If we might just add my ticket. My ticket is that. And I'm curious about the nature of this data, how easy this problem is going to be. Because what I want to do, I want to say for a given rule, I wonder how many positions are eligible to be that rule. So what I mean is, first I want to just check something. Are all the tickets the same length? I hope so, otherwise I've really misunderstood one of the fundamental things. Yep, they're all length 20. So there are 20 rules. Yep, 20 rules, perfect. And my ticket is the same. Yeah, that's a relief. Now, I'm just wondering, like, if we're looking at rule 1, the first rule here, I wonder how many fields we can narrow that down to. So what I want to do, we can just transpose this list and does transpose exist? No, we might have to write that one. Because what I'm saying is, if we take rule 1 and we take basically each column of this nearby matrix, I wonder which ones will actually work. So what I mean is, if we take like nearby, right? We just take the first element of each, the first value in each of the nearby tickets, and we ask, are they all valid for rule 1? And the answer is no. And that means that field 1 is not the one that corresponds to the first rule. Now I'm wondering if they've been very generous and made it so only one column possibly works for each one. That would be really nice, but we'll see. So let's just write a little function that say eligible, right? Is this rule, I might just refer to the rules by number. So is rule R eligible for field F? And these are both R and F are in 0 to 19. So is R eligible for F is the question I want to know the answer to. And the really cheaty and inefficient way to do this is to do this. So we'll go, I'm also wondering whether I need to look at my own ticket to determine which values are valid. Well, leave that out for now. Oh, no, we'll stick it in. So say all tickets is my ticket plus the nearby tickets. Yeah. So rule F is eligible for field F. Let's grab the values. So the values are map. So just dig out the F's field from all the tickets. And then we just want to say if all values are valid for the rule, which we can shorten to this. So we can ask, is rule 1 eligible, 0 eligible for field 0? Oh, it didn't like that. Oh, whoops, I mucked that up. The rule is not R, but it is rules. R. Okay, let's try that again. No, it isn't. Is rule R eligible for that one? No, no, no. In fact, is it eligible for any of them? No. Well, that's very unfortunate because now we've done something very wrong, and that's sad. Well, that's a shame. It's going so well. Let me think about this a bit more. So hang on. Based on the nearby, maybe we should look at their example and see if that works. The first position must be row. First position must be row because look, they all match. 3, 15, 5. The second position must be class. So this is 9, 1, 14. Why must this be class? I'm a bit scared of this example because why couldn't the second position be row? And the only answer to that is because we've already used row somewhere else. And that's a bit scary because it might mean we need a bit of clever logic. But we're not going to need any clever logic at all if we can't even get the basic thing to work. So let me think about this some more. The values are map F. So you map the field in all the tickets. Let's just check that that works. 61, 854, 358, 194, etc. And then we dig out the rth rule, right, which might be like that. And then we check that all of the values are valid for the rule. I might just write this just for debugging purposes. So out of all the rules and all the fields, all the pairs of rules and fields, how many are eligible? Bearing in mind our functions may be wrong. And I'm now just curious if I should only be looking at the nearby tickets. No, that didn't make any difference. That's a relief, but it hasn't given us it. Hasn't gotten us any closer to our answer. I mean, it's possible we got this wrong, but then we would have probably have failed the first part of the problem. So the problem is likely to lie in eligible. Certainly hope I didn't muck up copying in the input. That would be very bad news, but I don't think I got that wrong. It all looks pretty good to me. Yeah, I can't see that this is wrong. Yeah, this all looks good to me. So, what on earth is going on here? I'll tell you what we can do. We can try to do it a little bit manually. So let's say we're looking at that first rule, right? 31 to 221 and 241 to 952. What we can do is we can take the 0th field of all the tickets, right? And sort it. Well, you didn't like that. How about now? There we go. And we can just check it manually. Is this within the range? And what we're looking at is the biggest number. No, the biggest number is too big. So too big, too big. It's 952 is our maximum here. Too big. Oh, hello. This one is not too big, but it's too small on the other end. It's got the smallest number. Can't be any smaller than 31. Too small. Too small. Too big on the big end. Too small. Too small. Too small. Too small. Too big. Too big. Too big. Too small. Too big. Too big. Too big. Oh, I'm so dumb. I have to leave out the invalid tickets. Okay. I almost did it too. I almost filtered out the invalid tickets right at the start. I said, oh, no, we'll do that later. Okay, so how are we going to filter out the invalid tickets? So these are the all tickets. All valid tickets is what we want. Now, all valid tickets is simply all of the tickets, oops, filtered by whether or not the ticket is invalid. So before we were looking at invalid values, we need to look at invalid tickets. So a ticket is valid if all values within the ticket are, if all the values match at least one rule. So that's exactly what we had before. So it's that. And a shorthand, well, hang on. That's better. So now we're actually getting some real answers. Now we can shorten this if we're so inclined, like this and like this. There we go. Okay, so we have eligibility pairs now, which is a very good thing. I might just... Now we're going to remember which one is which. So there's R and F. I mean, the question is... This is like a linear assignment problem that I can't remember how to solve. We can do it in probably the naive way, and it will probably work. I was just thinking if I can print them out in a nice way. If I go pairs, if I go group them, and then, yeah, this will work. That should give me an... Oh, no. Group by... what's the type of group by? Group by equals I just want the first one. Yes, yeah, that's better. Just want to print them out just because here's a giveaway, right? So here's one that only works on one. And I was just wondering if the way it's going to work is you get that one and then it rules out this one down here because the second number 9 is taken, which means that must be that. And in fact, I wonder, I bet, if we sort it first, you're not going to like this, are you? You're going to complain, yeah. Interesting. Now, is it behaving the way I expect? Yes. So 6 goes with 9, 16 goes with 5, and that rules out 9 and 5, which makes 7 go with 2. And this has ruled out 9, 5, and 2, so that has to be 11. And this has ruled out 9, 5, 2, and 11. Yeah. So they've been very generous and given it to us in an order that it's going to be pretty neat, I think. So I reckon if we just whip through and assign them, having ordered them by length, we should arrive at a solution pretty quickly. So let's head over here. All right, let's try doing it like this. let so assign pairs equals, so just call it P's. All right, so we've got them in order. Let's just go loop. Yeah, let's just loop on that. So I'm getting here a list of, what are they called? A list of pairs grouped by the first one. So if I get, let's try this. If I get one that's just one pair, right? So it's just XY. Let's just return XY and continue the loop, deleting all of the ones that the Y, we've just stolen the Y, right? So I'll go map filter, and I want to delete all pairs A, B such that B equals Y across the pairs. Sorry, this is not correct. It's almost correct. It's got to be like this. So if the first element of our list of lists is a singleton list XY, then that's the correct assignment of that pair. And I'm going to loop over the rest. I'm going to filter out A and B. I'm going to filter from all the rest of them, any that we're trying to use Y as their second element. And continue the loop. Oh, didn't I? Yes, fair enough. Okay, now, so if I go assign, this will never work because I haven't written the base case for a start, but it looks very promising because it actually got to the end. And if I say if we're finished, we're finished. And I think that's it, right? Because if I now sort that, this is now telling me, oh, they all say 9. That does not seem correct, to put it mildly. Oh, filter's the wrong way around. We've got to filter, we've got to keep only the ones that are different. I want to filter out the ones that are equal. Let's try that again. It still worked. It's very nice. And it's telling me, if we remember what I did before, right? I did a little bit of manual computation. I put 6 with 9, 16 with 5, 7 with 2, and that's what I got, 7 with 2, 16 with 5, yeah. So what we've got there looks pretty good. Now, what did we have to do? We had to go and find the fields that start with the word departure. Now, they were the first 6. Memory serves, so 1, 2, 3, I need fields. All I need to do is take the first 6 here, those ones, pop them over here. So the fields of interest are exactly these ones. What's wrong with that? Why are you yelling at me? Don't get sad. What now? I left out a comma. There we go. So the fields of interest are fields 14, 0, 12, 6, 19, and 18 in my ticket. So map ticket fields. What's wrong with that? Oh, come on. Come on. Int and integer, they're basically the same thing. There you go. Happy now. And we need to take the product of those, I think it was. What do you get if you multiply those 6 fields together? Hopefully you get that. And we do. And there we are. That was kind of a fun one. A bit of a mixture of Don't bother parsing the input, hack around a nice interplay between the REPL over here and a bit of programming. That was fun, and thank you for watching.